So when we were left with a solution to our class problem, and we used, of course, the Pulp linear solver, which I think it uses simplex, I think, or what it uses some. It I think mentions which approach to use it, but it's basically, of course, very quick. But again, so our solution is breakfast is 1 and school 0.7. So basically, what do? We have to relax which condition, basically, right? We relax condition, so this means we have to branch now on what value? Not breakfast, breakfast is 1, we branch on school, which is 0 or 1, right? So 1 is infeasible, right? So we would check whether 0 is actually possible, right? So it looks like that's going to be probably the solution, right? That's probably going to be the solution, right? Let's look at all the different code. Let's first let's do a brute force approach, right? Just simply plug in all possible values here. We have to constraints, so you can do this easily, right? So yeah, we're going to do iter tools. Yeah, I think we do iter tools library. Let's do iter tools library. That's a pretty cool idea, right? So import iter tools, right? And so let's see if this is product, right? So all, again, assuming we don't know how to do 0 and 1, right? So all possible combinations, right? So we have the product of 0 and 1 2 times, right? Basically, right? Only two variables, right? So let's look at all combinations. Print combinations. Well, let me print them, right? Very cool. Testing the following. Testing the following combinations. Let's see, what does it say here? Okay, I don't know. Oh, I guess it's gonna like make pretty nice. All right. Combinations, right? Oh, let's gonna put. So what is this? Is, if I remember correctly, this is F strings has a nice little formatting, 10 spaces, I believe. It gives you nice little. Should look pretty nice. This looks pretty nice, right? Karma, right? Yeah, it looks pretty nice. So, right. Then again, we know this. Unfortunately, this is not feasible, right? So this is not feasible. So, and this is going to be the answer, basically, right? So you have to go to school but skip breakfast, unfortunately, right? Sadly, right? So not the other way around, right? 1 0, right? Breakfast but school, right? So we need to check both, actually, right? Actually here, right? We need to check the other way too. So check on breakfast and school, and then branch. So this was our upper limit is 15. Actually, if you're doing this right hand, right, if you're doing the branch and brown approach, right, so if we were doing the branch and bound approach, first we would calculate the optimal for a continuous case. Here it is no, well, this is not allowed. Here it is. Optimal life quantities. Since then you would branch on a school variable, right? Exactly. Thank you, AI. All right. Two subproblems. Let's see this breakfast 1 0, right? Breakfast 1 on school 1, right? On breakfast 1 on school 0, right? Well, this is infeasible. This is infeasible. This is sadly subproblem 1. It is infeasible because constraint x2. No, yeah. Because no, not because of that constraint, but because of this particular constraint, right? Because of this constraint. Yeah. Okay. Thank you, AI. Picked up on this, right? All right. So now this here we can solve it, right? And total karma is right. So the question is, of course, the actual solution, right? Here is actually 1, 0, 1. So we have to check this one as well, right? So to column 8, right? So this would give us also a possible solution, right? School 0, breakfast 1, right? Total karma 1. So this is the solution. So this would be lower bound, right? Lower bound for now, for the second problem, right? And then of course, then we have to check. Then on the breakfast variable, right? And you get two subproblems again. Breakfast 0, right? School, right? 0, and basically breakfast 1, and yeah, school 0, basically. So and of course, then this would have to be obviously we would end up with school being 1, right? So eventually, right? So here then we would end up with breakfast 1 and school 0 and total karma. No, school was breakfast. Was it? School was 11. What does it say? Oh yeah, 11. Oh yeah, of course, school 11. Yeah. School gives you more karma than the breakfast. Yeah, here we go. Breakfast 0. Sorry, on school 1. And school karma is 11. Yes, this would actually be the optimal solution for the integer case, right? Again, so here in our branch here with branch and bound we solve this. Well, we solve the in 3 steps again, right? But of course, we could do it also with the library, of course, right? In real life, right? So, and let's see what I'm gonna say. We skip. So what we gain here in this simple example. We gained almost nothing, except we did not have to check 0, 0. Check the infeasible solution, right? Yeah. But in a complex problem, we can say, okay, so let's do this. Let's see if we can make this branch and bound approach, right? So this will be a brute force. Right. So basically, I'll just copy this, right? And basically, all right, we'll do it over. Pulp for integers. So simply, let's double check. Of course, so category cat integer, right? Category integer. I think it was right. It's capital E, right? I think. Oops. I can't type. I think like this, right? Yeah, simply. And will it work? What happened here? Did I do something wrong? And I guess I did. Oh, I wonder why didn't this work? Or maybe I didn't read correctly. Cat. Integer. Sorry, integer. There's no. Now? Come on, what's happening here? It's not printing anything. Okay, now finally. Yeah, so breakfast and school, which of course again is pretty obvious, but at least it's like a sanity check before you do anything before. So it was cutting, right, checking. So now we could do, of course, now we could try to solve something really, like some multiple variable problem. Now let's come up with a more complex example. Let's stick with binary choices. but let's have, say, 8 decisions, right? So it's yes or no decision, but yeah, it's yes or no, yes or make, yes or no. Let's think what kind of problem do we want to solve? Let's think about it. What could be 8 possible choices? Like, I guess, what kind of toppings you want to get on pizza, right? Or something like that. I guess would be one way, right?
Ice cream flavors.
Yes, ice cream flavors. Okay, so the 8 choices will be 8 different ice cream, flavors. Yes, all right. Yes. Yeah, I hear you. So, all right. And what do you want? What are you going to be maximizing? Not calories, right? You just take everything then, right? Some sort of taste function. There's going to be a taste function, I guess, right? Or what else could we maximize? Well, optimal cost, right? I guess it could be the best. I guess the cost would be one. That's kind of So taste or cost? What do we want to optimize? Taste, yeah. So okay, there will be a taste function. Yeah, taste function. Right. We want to optimize the total taste. Right. All right. What else could we do? Right. Also. Right. So that will be taste. Okay, that sounds good. And also, it's pretty easy to do a constraint. Okay, 8 is silly. Let's do no more than 5. That's very easy. You have a constraint x1. All the values together has to be at least 5 or less, and that's easy. You solve them. You create a constraint. No more than 5 variables can be yes. Right, very easy constraint to add. So we'll add this. Right. Also, finally, the constraint will be that no more than 5 varieties can be chosen. So yeah, so you don't get sick. Right, okay. All right. Yes, we will use okay, but first we need I guess we'll need a taste function, right? Taste function. All right. First let's come up with taste function. I guess I don't know what we need. I don't know what we need. Okay, so vanilla, chocolate, strawberry, mint, caramel, pistachio, banana, coconut. All right. Okay. All those look good. I'm getting an itching to go to what's it called Molbert's in Old Riga, right? You know that place, right? Pretty good ice cream there. All right. So yeah. All right. Let's create problems of taste. We have. Yeah. But we don't still have the problem. Okay, so problem ice cream, right? And let's see if we get any decision as floats. But we can actually do binary. Oh, that's really cool. Look at this. This is kind of cool. We can provide a special binary. This is kind of cool, right? Instead of doing one by one. Hopefully this works, right? We don't have a taste function, right? Well, function. Yeah, objective function. All right. Yeah, okay, because that's this problem. Some flavors, flavor for flavor, and flavors. So that's pretty cool. This looks like a nice generator function. All right. I wonder if this is going to work. This works. This is pretty cool, actually, right? So this means you don't have to do this all by hand. Basically, you can use dictionary, right? This is really cool, actually. If this works, actually, right? So basically, it's much easier way to work. So these are all linear. These are basically the multipliers for each variable, right? So you don't have to do it by hand, basically, right? Maybe less readable at the moment, but actually pretty nice. If this works, actually, this will be fantastic. Well, we'll see. Now, right? We have function. We want to maximize this, right? On constraint. We need some constraints, right? Right. So some flavors, flavor for flavor and flavors. For flavor and flavors. That's not what I want. No. Let's see. Oh yeah, flavors, flavors for flavor. flavor for flavor. Yeah. Okay. Oh yeah. But do I have this? But, oh yeah, that's it. Okay. Yeah, this is binary. Okay. also, could we create also, I guess we could create also, let's add the constraint that, oh, we can't have vanilla and chocolate at the same time. Okay, let's do that. Right, so it's also easy that, so flavors vanilla plus flavor chocolate less or equal 1. So we can have no chocolate, no vanilla, right, but, right, okay. Let's see if we can solve this, right? So what are we going to come up with this amazing, so apparently coconut, well, we'll probably go coconut, vanilla and chocolate. It's not really, well, they're pretty important, but not the most important. So we'll have a coconut pistachio, and then, well, probably vanilla and mint, probably, I'm gonna guess, right? Caramel, vanilla, and mint, I don't know, 5, right? Let's see what happens. This is an easy example. Let's see what happens. Solve the problem. Let's take a look. And we want to print it, right? We solve it, and what do we want to do? Solve it and print the optimal solution, right? Let's print the solution. Let's print the optimal solution. Oh, sorry, no, I will not even make it. Let's print this. Let's print the optimal. All right. For flavor, print flavor. Right. Very good. And print total taste. Problem objective. Okay. So this is actually a pretty cool example because it shows you how you can add like basically multiple variables. Actually, this pulp function is pretty nice because again, in real life you're not going to have only 2 variables. You're going to have probably 50 variables, right? So this approach, again, do you guys know what you know Python dictionary, right? So this approach is pretty neat, right? So you just add the linear constants. It's easy to edit, right? You can get from a from a JSON file or something, easy to import, right? Something like that, and make a dictionary out of that, and use that. So let's see if this works. If it works, great. If it doesn't, well, we'll go back to the drawing board. Now let's see. Okay. So caramel, pistachio, coconut. Total taste 34. That's it. So only 3. Caramel, pistachio, coconut. Let's see. How did that happen? Caramel. Caramel, pistachio, coconut. So that's 3. But the question is now, why didn't we add vanilla? Oh, chocolate. What's happened to chocolate? I don't see chocolate. This is kind of weird, right? Why are we? Output is truncate. Okay, that's probably why, right? So it's probably because try to do a lot of solving, right? So how many? Again, well, we have some constraints, but in general, if you did the complete brute force, so how many possible choices do we have actually? In general case, how many? If I had brute force, I'd test all possible solutions. How many solutions do I have to check? If you don't even know about constraints, you just have, okay, 8 possible flavors, and I can put all 8 or put none. No, nothing as crazy as that. How many? I chose 8 for a reason, like a tiny hint, right? How many? It's exponential, it's exponential, right? So you have 3 choices, right? I can choose each one in 2 ways, right? So it's 2 to the 3rd. So we have 8 choices. It is 2 to the 8, which is, you should know this in the middle of night, right? 2 to the 8. 2 to the 8. If you get a call in the middle of night, what's 2 to the 8 power?
256.
Yeah, of course. It should be 256, right? That's like it's like 100 basically. That's like the the number which is everywhere, right? Because of course it's a single byte. Is 8 bits, right? So you can think of these as each bit basically, right? Choice 0, 1, 0, 1, 0, 1. So 8 is what we use for chunking together, right? Or basic data, right? So it's everywhere, right? 256, right? So I'm not going to ask you what's 2 to the 16th, right? You probably know that too. 65,536 or 366, 365? No, 536 I think, right? But I'm not sure, right? And then of course 2 to the 32 to the 32 is about 4 billion, right? Something, right? So, but 256 of course is important. Now, so we have to check 256 possible choices, but we have some constraints, but I'm still kind of worried. So this is kind of weird. I don't know, maybe we did something wrong. So only 34. Let's first of all let's see if this makes sense. 34. Yeah, no, it doesn't make sense. So this means it's actually everything's correct except it just didn't print it, right? This is too much. So I will solve. Can I make it here? Solve problem B. So problem turn off verbose. Yeah. Okay, let's do that. See if this works. I'm gonna see if this works. I don't know. This is pretty cool if it works. Yeah, works. Okay. Yeah. All right. So outcome choice, right? We could of course we can print flavor, right? Taste flavor, right? And of course, right? Right, 7-4. So again, you see why it worked correctly, because it did not choose choice vanilla and chocolate. Obviously chose chocolate. Why? Because of course here chocolate gave you better bang for the buck, basically, right? Apparently, I guess coconut. Is coconut really that high? Well, pistachio is pretty good. Everyone likes pistachios.
Yeah.
Yeah. Coconut, not so much. So coconut carums. Not so much.
Very
We see, it's a division. It's a divisive issue, right? So yeah. What about the new carums? I have not tried yet the menu, the anniversary one. No, I haven't tried. I haven't seen it either. They had the ads there somewhere.
My favorite is chocolate and ice cream.
Okay, yeah.
There was this one, marble.
Yes. Okay. Yeah. And I like coconut. I like chocolate. I try different things, but I don't like the what you call sukads. I don't like the sukads carums.
I think I just like all of them.
All right. Okay. All right. So yeah, this again still the question, of course, here again we have some constraints. Again, this is also not even if you had like maybe 50,000, I don't know, 1,000 tastes, 1,000 possible values, and you have these constraints. Well. It's still relatively easy, I think, for binaries, because, well, you can, again, start, if the formula is really easy here, you have these values, these are linear values, right? You can start the ones, of course, the greedy approach. Take coconut first, pistachio, right? And then you go until you have some constraint is violated, right? The problem, of course, is if these constraints are, there's some, interlocking, right? So then your greedy approach will fail, right? And you take a choice, okay, I'm going to ignore vanilla, right, I'll take chocolate, but then it turns out chocolate also doesn't work with something else, right, with mint, right? And then you have a problem, right? Because then vanilla and mint would be better than chocolate, basically, right? So, yeah, so greedy approach again would not, a pure greedy approach would not work. That's why I'll add the note to this. Yeah, note, with some constraint, with some minimal constraints, we could have used the brute force. Not brute force, but the greedy algorithm. Simply start with the best linear flavor, highest linear coefficient, right? Exactly, and keep adding flavors until we reach a constraint, right? Unfortunately, in general case, this is not going to work, because we could have some constraints, make the greedy, right? We pick some flavor, or yeah. All right, so that's something to note. Okay, but yeah, this is I like this actually. This is like I like this. This is we learned something how we could use it for multiple binary approaches. So markdown, multiple binary approaches, multiple binary variables. No, so this actually we could actually solve this actually. Try another problem where we have a more choice than zero, not binary, right? So basically, category, right? Taste keys, right? Say, okay, these are all. You could have mixture, perhaps, right? Also, probably, right? So we can have continuous, of course, you know, continuous or integer, right? Then of course, then we'll need this is kind of nice binary. But let's say we have how about 0, 1, 2, right? Well, if you have like three values, right? We use this approach from Soviet computer from 1960s, which had a ternary logic, right? You only three choices: yes, no, or maybe, basically, right? It is a really rare computer, but yeah. So we could like simulate that. So maybe you have three choices, not just two, right? Sort of like maybe or like halfway, right? Of course, you can say 0, 5, but let's say 0, 1, 2, right? We'll do 0, 1, 2, right? Let's do that. Now let's do something a little more complex. Now, okay. Oh, come on, where's my, I'm not, okay. Come on, okay. Let's do the same problem, the same flavor values, but we will allow for three possible three possible for variables to have three values. You know, 0 for no ice cream, 1 some ice cream, some lot of ice cream, right? No flavor, no flavor, some flavor, full flavor. All right. Or three flavors at a time. Four flavors time. All right. Ice cream. That's floats. Well, let's see. This is floats. Integer. Oh, here it is. Easy. 0, 2 integer. Right. You see, it's yeah. So we can use these. We are going to use yeah. You don't need the floats. Objective function, right? 0, 1, 2, upper bound, lower bound, so this is inclusive. So up, low bound, those are inclusive, right? And are inclusive, which is a very important point, right? Because many times upper bound is not inclusive, right? So very cool. And of course, now we can get the objective, right? Objective function, find the constraints, right? We can have more than 4 flavors, so this means up to 8. No, some flavors flavor for flavor in less than equal 4. Let's see if this is actually. Yeah, because these are the lower bounds. Okay, that's fine. Let's see if this will work. I don't know about this. This might be okay. Right. But this we can have partials. But this essentially means we can go half and half. Yeah. Right. So this technically means we can have 4 flavors half. We can have 4 half or 2 full flavors. Or we could have 1 full flavor and 2 half flavors, right? Yeah. All right. Okay. And finally, let's check what happens if anything changes. Solve the problem. I don't know if it's going to work. Print the taste. Come on. All right. I don't know if it might break. Looks like it works. Spaces are not permitted. Oh, but it works. So in this particular case, it's trivial solution, right? Where did I? Oh, ice cream. Okay, I guess I need to do this. Ice cream. Sorry. Yeah, ice cream. Yeah. Okay, so in this particular case it was really easy. Why? Because of course we had pistachio and coconut, right? So I guess I'll make pistachio and coconut well, again, what's going to happen is probably going to have in this particular case, it will just keep we make some weird constraint, right? So this is okay. We can add some more constraints, basically, right? We can add the pistachio and coconut is not, I don't think doesn't go together. So same. Let's add constraint that pistachio. Yeah. All right. So now we'll have something different. So we'll probably have pistachio. No, we'll have coconut on probably whatever is chocolate. Coconut chocolate. I guess that works, right? Right. Yep. Indeed. Again, not very shocking, but easily. Again. So some conclusions. So again, solution here was pretty obvious. We got pistachio, we got coconut on chocolate as full flavors. This greedy we have work here as well, right? I'm trying to see if find I don't want to think about think of approaches, think of more where greedy algorithm would fail, right? Because I'm trying to see where the greedy approach would fail, basically, right? So, right, just basically pick the maximum, right? Some flavor, full flavor, right? So again, what I want to show you, basically, you can model. It seems like linear program steps, only have linear functions, right? You have, of course, in real life, you have quadratic functions, log functions, and so on. But for choices, right, you can model a problem using these 0, 1, 2, integer values for choices. You can have a mixture, right? You have some continuous variables, right? And also you have these choices. Okay, so let's do this one last thing before we finish this task, basically. For partial, let's combine it, right? Let's do a more combination. We will combine. We'll use the existing flavors, right? But we will also have two continuous variables like we have a budget of 10. We'll have to buy the ice cream. We will have to. Right. So we could have the pricing for this, right? We have the flavor. We'll have on right. We will have to buy the ice cream. Okay. Yeah. Total taste. Right. This will be much harder, right? Ice cream. All right. So that's fine. Now we need. Come on, we need some prices. Yeah, prices. Right. Pistachio, yeah, so these are prices, and now we can add those. How do we add? Budget, right, that's our budget bound, right, upper bound, 10, right? Budget is up to no, let's do 15. Let's do 15, right? 15, right? So we can buy something at least, right? Lower bound and then upper bound, right? Upper bound 15. Okay, it's continuous variable, right? Okay, then we can buy things, right? That will make things harder, right? I think this will work. All right. That's the objective. Some flavor for flavor. Right. Right. Okay. It's not finishing. It's boring. Looks okay. So let's think how this would work. So you have 2 times coconut, right? You can't have. So this is going to be harder problem actually, right? So coconut costs 8 and gives you taste, right? So let's see if this works actually. I don't know. Oh no, I guess you cannot. Well, yeah, it's fine. Pistachio and coconut. All right, let's solve this. I don't know if it's solvable. We'll have some solution which is not going to be obvious, right? For flavors, right? Oh, let's print total taste, right? So let's see if this works. Actually, I don't know. Is this actually going to break? It actually worked. So chocolate, caramel, pistachio. But now only thing is, all right, if value, right? But I want also the value. Right, how much of this, right? It's obviously not all of them, right? I want to see the value, also value. I'll do this. Print flavor, taste, value, right? Yeah, let's do that. Right. Flavor, taste, value. So comment this out, right? Print F. Yeah, exactly. Thank you. Amount. I like this. This looks gonna look good, I hope. Yep. All right. So we have our optimal solution. So let's see if this actually fits in the budget. Okay, the price. I want to also do the price, right? Is this actually gonna work? And price, right? Price. Do also price amount. Price spent. So price on cost, right? Price and cost. Price per kilo, I guess kilo, price giga, and cost, right? Yeah, well, there we go. Okay, now this means we need to add these things. Okay, so let's do it one more time. All right, will this work? It should, right? So price flavor, yeah, price flavor times value. Okay. Let's see this works. Yep, okay. So price 2, so really cheap, right? Chocolate is really cheap. So 2 kilo per kilo, I guess that's what we did, right? Yeah. All right, that's the best deal. You start with chocolate, you just load up on the chocolate. That's actually, you know, in real life, of course, now we know chocolate is going up, right? Price of chocolate is right now up in markets, right? So hard times ahead of us, right? So for those who are chocolateholics, I guess, right? So, but this looks good, right? So this is actually pretty nice examples how, well, this library, right? Again, of course, we offload all the hard work of the branch and bounding, right, to this library. But hopefully it gives you an example how you could solve this problem and get some results, actually, as well as in real life, actually, right? So how you can model this problem. All right, so again, next week we start on graphs. We already saw some trees which are part of graphs, and we already, of course, experienced graphs before, but now we'll start looking heavily into graph algorithms for next week. Any questions on the branch and bound approach today? No? All right, I'll save this, so maybe this can help anybody. All right, we'll use it's 11:10.